describe a problem before we are talking about the coding. So let's say, like a real life example, there's a task which is saying that we want 5 rectangles and there will be squares for this case, and we want to space them equally, and from the left also the same space as between them, which is 20 for this case, and window size is already given as 600 by 600. So this is a problem described. So as a programmer we have to analyze this problem and then think about how we can convert it to a Java problem. So now, since the space is given, there's a constraint. For any design problem there are constraints which we are not able to touch, and then there are variables which we are able to adjust them. So in this case this 20 is given. So if you see on the screen, 1, 2, 3, 4, 5, 6 spaces are equally there. So it means 6 times 20 will be total 120. That is from the window width. That space should be used for spaces. So then, since the screen width is 600, the rectangles will occupy the space which is left behind after you take out the intervals. It means 600 minus 120, which will be 480. This 480 means the total width of 5 rectangles. Then if there are 5 rectangles, so when you divide by 5 you will find the width of the rectangle. It means for this project, to be able to draw these rectangles equally spaced, and then space is 20 and screen size is given, we have no option but find 96 as the width of the rectangle. So this can be a very simple task which we are supposed to implement in Java. So now, if you want to go through the calculations which are necessary for implementing the Java code, the Java code for this case is fill rectangle only. We will go through in the project later. But now we know that fill rectangle requires 4 parameters. 2 of them is top left corner of the rectangle. For example, 20, 20. It means this first rectangle, the top left corner coordinate should be from the left 20 and from top 20. And the width of the rectangle is given as 96 and the height is same. So it means this command here will be able to draw a rectangle on the screen as shown. So then, because we need 5 of them, we have to calculate the second rectangle top left corner. So only changing parameter is the distance from the left. That's why you see the 20 plus a rectangle width plus another space will give total distance of the second rectangle from the left side, which is 136. So 136 means from the left of the screen, the top left corner 136, and then the other parameters are same exactly. So this command will be able to draw the second rectangle. Then if you continue like this, the other rectangle will be another rectangle end space shifted. If you make the calculation, you'll find it is 252, and that's also calculated. And then similarly the other one will be 368 and then 484. So all the numbers are now on our hand. It means if you write these comments after each other, we are able to draw these rectangles. I will show you in Eclipse after we go through our theory. So now let's see. The Java code will be like this. After each other you write them, and then when you run this it will be displaying these rectangles. So we will talk about this graphical environment many times. So you have to get the structure as is and know that all our calculations and everything will be in this background panel. In this case we don't have anything but writing 5 times fill rectangle command. But this is not a perfect way of describing a problem and solving as a programmer. So now the same task we will generalize it, which is more suitable to design a problem which can be generic. So instead of saying the top one showing the previous one, and the same task we will now generalize, and the second description is here. We will see we want to draw n squares equally spaced on the screen. In this case n will be 5. It means 5 squares equally spaced. Then the constraint will be screen size is given as SW and SH. It will be assigned to be 600, but it is a variable so that the design can be generalized. And similarly, we will see the space between shapes horizontally is X space, and then we will not go to second row right now, but the top space will be called Y space. So with these parameters given, we will go to Eclipse environment and then use this information how we can make a generic variable oriented programming. It means we will our structure will be first a problem definition, and then making them formulate them with the variables. Some of them are known, some of them are not known. For example, in this case, a number of squares is given. It is assigned to 5, and then screen width is given SW and SH, and also here X space and Y space is given as, for this case it can be 20, it can be anything else later, and which is not defined yet. We will describe in the Eclipse environment. The width of the rectangle will be calculated based on the other variables. Now we will go to Eclipse environment and then implement the first task here with the, we call it hard-coded, with the numbers only, without really thinking about the variables, and then it is a specific solution for specific issue which is not advisable for a programmer. Then we will go with detail how to implement the same task with the variables. To start our Java 008 example, I will call it variables 03, but in the same concept we have to implement variables 03 A and B, so we can know that we are using two examples in different projects. So we will use the same project which was used before, which is basically there is a mainframe which is producing a frame only, and the content of the frame is a panel, and that panel is designed by ourselves by extending the standard J panel which is here. So this is very important to get this structure well. You should be able to type this structure from beginning to end, or you should be able to import this structure and change it as you like, but you should get familiar with it as much as you can. So now I will take this 07, copy and paste, and call it 08, and it is variables 03, and I will call it A. Copy. Now this is the project which is supposed to be changed according to our desire, but to make sure we are not making mistake, I will close all others. Right click, close unrelated projects. Okay, now this project is exactly same as 007, and we will clean it to make it ready for the new project. What we need, we clean this part, and we will not use it for this case, and we clean this part, and I will leave this so that you get used to constructor, although we will not using right now. I will say initialize here, but we are not initializing anything right now. And this part we will change it such that it will implement our 5 rectangles the way we calculated in our slide. So let me go back to slide to remember our coordinates. So here are the examples. So the variables first, the first coordinate is 20, and the 136, 252, 368, 484. The rest are all same. So I will go back to Eclipse and say here 20, comma 20, comma 96 and 96. This will be our first rectangle. We can run and see. We are supposed to click here for running it. This is our first rectangle. Now I will copy and paste second one. It is 136. I don't remember. Let me see if it's correct. 136. 136. Then I run it and see there's a second rectangle. Yes. And now I copy and paste for the third one, which is 252. And then I will copy the others also, which is, I don't remember, 368, 484. 368. Run it now. These are the rectangles. So we call this hard-coded. So this is designed only by the numbers, and if you want to make any change in your design, you have to go back and then change all these numbers. So this is not a good example, but it shows how these commands are producing those rectangles. So if you are not comfortable with the numbers, think about this screen to be 600 by 600, and then if this is all 600, and then is this 20 plus 96 plus 20, 96, and go through all and then understand the numbers well. Then we will do the same thing by variables. So what we'll do, we'll go back to the same 7, copy and paste, whoop, because it's not open, copy and paste, and then call it 8 03b. B means with the variables. Now I will close the previous one. I will close others. And now we will clean up. This is our graphical environment again. So constructor here, but because we will be using them, I will not clean everything right now. So let's go back to our design and see if these variables are shaped accordingly. So of course this example is the same as before. The variables are used, but we want to understand how we are able to first describe a problem and then use the variables to solve the problem. So let's go back to our slide. We need n square equally spaced. So let's go to code again. So here I will say a variable definition n, in this case it's 5. We need 5 rectangles. So the rectangles width are given as w and h. We describe like that, w and h. And screen width is given as 600. And we will use the variables sw and sh. And here, from the previous example, we are taking this out. We don't know the w and h yet. We will say our space is known, our x space is known, which is, to make it clear, I will take this out here. X space is equal to 20 and y space is equal to 20. It can be described here or it can be described here. So this is same as, I will make the other way. You say integer, only define it, and when you come here you say x space is equal to 20 and y space is equal to 20. So these are the constraints. They are given. We cannot play with them for this specific problem. They are given. But what's not given is the w and h. W and h. We don't know yet. H, we don't know. So based on our calculation, let's go back to calculation again. What we said, the total space is 6 times 20. It means 6 times x space. So it means I will do it here. I will say SW, the screen width, minus n times n plus 1, n plus 1 times x space. This is total space occupied by intervals, the space in between the shapes. So if you take this out, you will be finding the total width of the rectangles. So I will say the width is equal to this divided by n. So if it looks complicated, we are able to use the dummy variables in between to make the calculation easy. For example, I will say integer total space is equal to, because there are n shapes, then there should be n plus 1 interval. Then I will say n plus 1 times x space will be space between the shapes, total space. Then I will say integer all shapes, means if you put all shapes together, their width will be total SW minus total space. So all shapes means that you put all the shapes together, 5 of them. Total length will be whatever left from the screen width minus total space. Now all shapes means 5 shapes, right? Then we will say, I will put this comment so we don't forget about this. I will say W is equal to all shapes divided by n. And for the H, for now, we are not going vertically. We don't have to make calculation right now, and they are square. So I will say H is equal to W, means same as width. Now with W and H is known. If you now consider this part as constructor, so now get familiar to class structure. So this is our class. When we are initializing this class, which is in the mainframe, I go to mainframe now. See, background panel is new background panel. We initialize. As soon as we initialize, the constructor part is working. Then you go back to background panel and see the constructor. Constructor is using the class variables, they are here, and calculating the missing ones, initializing the necessary ones, and after the constructor is running, everything is ready. So that paint component will be called whenever the screen is being refreshed, and we are drawing everything in the paint component section. So now in the paint component section, any variable we are using should be already defined in the class variables or the constructor or something called before this happens. So since SW, SH, X space, Y space, W and H are all defined, then we can draw our rectangle, the first rectangle, by saying that X space, Y space, W and H. This is the first rectangle. Let me go and run this one. We have to be here to call it and run it properly. So now this is the first rectangle, but it is designed by variables. See, X space, Y space, W and H. They are all calculated according to given variables. Now we want to make the second one to the right. So we have to shift X space to the right. So for this case, I will describe another variable which is in the class variable integer x and y. This means anytime when I use x and y, I will consider it is described for top left corner of the rectangle. So at this moment, because x space and y space for the first coordinates, I will put here x is equal to x space and y is equal to y space. We will be using another variable instead of x space and y space. Why? You will understand after the second rectangle. It means we will update x and y to show a new location, but x space and y space are fixed variables. So instead of using this first rectangle with x space, we are saying x and y. Now if you run, you will see the similar output, not similar, exact same output, but it is more generic. Why? You will see it in a moment. Now our second rectangle will be, let me show you here. Our rectangle is supposed to be shifted to the right as much as the x coordinate is changed, amount of the width of the rectangle plus the space. It means after this, if you say x is equal to, the previous x was already that corner, right? So you will say x plus width plus x space. So here we are updating the x. See, this doesn't look like the math algebra. X will not cancel each other. This says the right hand side is the calculation coming from the variables already defined. X is known, w is known, x space is known, and then if you collect those variables from those boxes belong to that variables, then you are calculating a new value, and then by putting x on the left, you are saying that I want to assign this information to the x again. It means after this line, x is updated. Now it is not top left corner of the first rectangle anymore. It is shifted to the right. Now if you draw the same comment, it will draw different rectangle. See, in line 30, x is 20 by 20. X is 20. But when you come back to line 32, you are adding 20 plus 96. Why 96? Because we calculated over here all shapes divided by n, 96, plus another space, which is 20. It will be 130. What was it? 130. 136. It is 136. Now I will see here x is now 136. Here x is 20. But you don't have to know the numbers, huh? It's calculating for you. So now if you run it, you will see two rectangles. Two rectangles. So we are repeating exactly the same command, but because we are updating the variable used, we are having another location, another rectangle. So now we continue by copying these two lines. It means we will update x again with the amount of w and x space added to it. That's why it's shift to the right. Now x is 252. 252. And now you run it and see that third rectangle is there. You see the same command, same two lines, copy and paste, but because we are updating x, it is becoming another rectangle. So now the value is, I have to memorize those things, but I didn't. 368, 484. And when you run now, you will see the four rectangles. So the importance of this way of solving the problem, we can speak a lot of benefits. Number one, it is generic. Number two, it is errorless, means that it doesn't cause any error because we are calculating everything by variables, so you don't have to remember the numbers. And then there is no redundancy. It means when you copy and paste, it will be doing the exactly same without any error. And later we will talk about the loops. It will help us think about iteration and generalizing more, and putting them in the loop will be another benefit. And most importantly, you are able to solve any problem with a general approach. It means you can implement your solution for different specific cases. And this is it for today. Thank you.